Welcome to section 2.2, conditional statements, and this is in geometry. Now, to start you off with, here's a classic. How does a cow do math? If you say it's with a calculator, you would be correct. Okay, let's start by talking about the truth value. So the truth value of a statement is simply whether that statement is true or false. Okay. If it's false, you can show that something is false by using a counterexample. If it's true, then you don't need a counterexample. Okay, the negation means it's basically the opposite. You could say the sky is blue. When you negate that statement, you're doing the sky is not blue. So it's very similar to opposite. I'll just leave it as that. Okay. Or the opposite of red is not red. Something like that. Okay, so conditional statements we have already talked about. Those are statements that are in the form if this, then this. And they have a hypothesis and conclusion. If the hypothesis, then the conclusion happens. Now, we've already talked about that the hypothesis we use as P. So we simply say if P, then Q, which stands for our conclusion. In symbol notation, that's going to look like this. P implies Q. All right. The converse is when we exchange the hypothesis and the conclusion. So if Q, then P. Now in symbols, that's going to look Q, then P. All right. The inverse, go back up to the original conditional, and then you need to negate it. And to show that you negate it, we use the not, or we call it a tilde for the symbol. So this is going to look like if not P, then not Q. So not is the tilde, P implies not Q. Now, can you think of the only combination that you have left for a contrapositive? It's going to be when you switch the inverse, basically. If not Q, then not P. So we say not Q implies not P. Now you need to know the definition of each of these four statements and their symbols. So conditional is your starting point. If P, then Q. The converse is when you switch the conditional. If Q, then P. All right, the inverse is when you negate the conditional. Not P, then not Q. And finally, the contrapositive, you need to switch the inverse. If not Q, then not P. Okay, let's practice this again. We want to rewrite the conditional statement in if-then form. So first of all, an angle that measures 15 degrees is an acute angle. There are several ways to rewrite this as a conditional. And a variety of them will work. I'm going to say if the angle measures 15 degrees, then it is acute. If you have another way, you can choose to rewrite it a different way. Okay, is that true? If the angle measures 15 degrees, is that acute angle? Yes. So for the truth value, we're just going to put T for true. All right, converse. Now remember, you have to switch the hypothesis and the conclusion. So to do that, I'm going to go back up to my conditional, and I'm going to underline my hypothesis one time. The angle measures 15 degrees. My conclusion is it is acute. I'm going to underline that 2 times. So when I switch them, my statement's going to read, if the angle is acute, then it measures 15 degrees. Is that true? If it's acute, it can only be 15 degrees. No, that's false. A counterexample might be a 30-degree angle. It is still acute, but it is not 15 degrees. Okay, now let's take the conditional and write it as the inverse. And the inverse is not P implies not Q. Okay, so if the angle does not measure 15 degrees, then we say the angle is not acute. Is that true? So think about it. Can you provide a counterexample? The counterexample must show that the hypothesis is still true, but the conclusion is false. So if the angle does not measure 15 degrees, is it not acute? That's false, because it could measure 30 degrees, right? And it could be acute. So that one is going to be false. Okay, contrapositive. Now contrapositive is, remember, when you switch not Q with not P. It's a switching of the inverse. So I say if the angle is not acute, then it does not measure 15 degrees. Is that true? Can the angle not be acute but still measure 15 degrees? No, that can't happen. So yes, this is true. If it is not acute, it cannot be 15 degrees. It cannot be any degrees between 0 and less than 90. Logically equivalent statements, then, are those statements with the same truth value. So if you think about our 4 main statements that we've talked about, conditional, the converse, the inverse, and the contrapositive. On our last example, we had the conditional was true, the converse is false, the inverse was false, and the contrapositive was true. So those statements that are logically equivalent would be conditional and contrapositive, and then the converse and the inverse. And those are always going to be logically equivalent. Okay? So whatever the conditional meant, the contrapositive has the same meaning. Whatever the converse means, the inverse means the same thing.